Carbide burrs are essential tools in a welder's toolkit, especially when it comes to the crucial stage of post-weld finishing. After the intense heat and energy of welding have fused pieces of metal together, the resulting weld often bears the marks of the process: rough surfaces, uneven beads, spatter, and other imperfections. These irregularities not only affect the appearance of the weld, but can also impact its performance, especially if the component requires further processing, painting, or coating. To achieve a professional finish and prepare the weld for its next stage, welders turn to carbide burrs, rotary cutting tools made from tungsten carbide, renowned for their exceptional hardness, durability, and resistance to heat. Carbide burrs are designed to grind, deburr, shape, and smooth metal surfaces with remarkable precision. The cutting edges, known as flutes, come in various arrangements: single cut for fine control, double cut for faster material removal and a finer finish, and specialized cuts for materials like aluminum to prevent clogging. Their shapes are equally varied: cylindrical for flat surfaces, ball-shaped for curves, tree or flame for access to tight spots and contours, making them adaptable to the diverse challenges welds present. These features make carbide burrs especially effective for use on hard metals such as steel, stainless steel, cast iron, and titanium, which are commonly encountered in welding projects. Before putting carbide burrs to work, preparation is critical. Safety is always the top priority. Welders outfit themselves with personal protective equipment, including safety glasses to shield their eyes from flying debris, gloves to protect their hands, a face shield for comprehensive coverage, and ear protection to muffle the high-pitched noise of grinding. The welder then carefully inspects the weld, identifying imperfections such as spatter, uneven beads, slag, or sharp edges that need attention. Selecting the right burr for the job is a nuanced process. The geometry of the weld dictates the burr shape: cylindrical for broad, flat welds, ball or spherical for intricate or curved areas, tree or flame for hard-to-reach corners. The type of cut is chosen based on the metal and the desired finish. Double-cut burrs are favored for steel due to their efficiency and ability to produce a smoother surface. Size matters too. Burrs typically come with shank diameters of 1/8 to 1/4 inch, matched to the rotary tool and the scale of the weld. The rotary tool itself, a die grinder, pneumatic grinder, or electric rotary tool, must be in good condition and capable of spinning the burr at the recommended speed, usually between 10,000 and 30,000 revolutions per minute. This high speed is essential for effective cutting, but it also requires careful handling to maintain control and safety. Once the equipment is ready, the next step is to set up the workpiece. The welded part is securely clamped or fixtured to prevent any movement during grinding. This not only ensures accuracy, but also keeps the process safe. Any loose slag or debris is brushed away, and the workpiece is positioned at a comfortable height and angle, allowing the welder to maintain a steady hand and clear view of the weld. Attaching the carbide burr to the tool, the welder ensures that it is firmly seated in the collet or chuck. The tool's speed is double-checked to align with the burr's specifications, minimizing the risk of overheating or premature wear. Now comes the actual smoothing process. The welder applies the carbide burr to the weld, using light, consistent pressure. It's important to let the tool do the work. Forcing the burr can cause it to dig into the metal, create gouges, or wear out quickly. With smooth, controlled motions, often sweeping or circular, the burr is moved along the weld bead, gradually blending it into the surrounding base metal. An optimal angle of attack, typically between 15 and 30 degrees, is maintained to maximize cutting efficiency and control. Material removal is a progressive process. The welder begins by addressing the most obvious high spots, spatter, or excess weld metal. As the surface becomes smoother, technique shifts to refinement, focusing on blending and creating a uniform appearance. To avoid overheating, especially on heat-sensitive metals like stainless steel, the welder may work in short bursts and allow the workpiece to cool periodically. In some settings, compressed air or a coolant mist is used to keep temperatures in check. Blending is particularly important for welds that will be visible or subjected to further finishing. A seamless transition between the weld and the base metal not only looks professional, but also reduces stress concentrations that could lead to failure under load. For intricate welds or areas with complex geometry, smaller or specially shaped burrs are employed, allowing the welder to access tight corners, fillets, or contoured sections. Carbide burrs serve several roles in this process. They are used to remove welding spatter, eliminate slag inclusions, and smooth out uneven beads that could weaken the joint or detract from its appearance. When a specific weld profile is required, such as a beveled edge or a precise fillet, the burr is used to shape the weld accordingly. In preparation for painting, powder coating, or further machining, the burr creates a uniform surface texture and removes any oxides. Once the smoothing is complete, the welder inspects the weld for uniformity, checking for any remaining imperfections, gouges, or undercuts. The surface is cleaned with a wire brush or solvent to remove any debris produced during grinding. For projects requiring a high-quality finish, the weld may be further polished using finer abrasives or polishing pads to achieve a mirror-like surface. After use, the carbide burr itself is cleaned, often with a wire brush or chemical cleaner, to remove any metal buildup and checked for wear. Throughout the process, a number of best practices are adhered to. Overheating is carefully avoided, as it can damage both the burr and the workpiece. Vibration is minimized through proper grip and tool speed, reducing fatigue and maintaining control. The condition of both the burr and the tool are regularly checked to ensure safe, effective operation. Good ventilation is maintained, or dust extraction systems are used to protect the welder from inhaling fine metal particles. The use of carbide burrs offers numerous advantages. They allow for precise, detailed work, essential for intricate or small welds. Their versatility makes them suitable for a wide range of metals and welding techniques. The durability of tungsten carbide means these tools have a long service life, even when used on tough materials. Perhaps most importantly, they make the process of smoothing welds faster and more efficient than manual methods like filing or sanding. However, using carbide burrs does require skill and experience. Removing too much material can weaken the weld, and excessive grinding on thin or heat-sensitive metals can cause warping or discoloration. High-quality burrs represent a significant investment, but their performance and longevity make them worthwhile for professionals. In practice, the workflow is straightforward, but demands attention to detail. A welder addressing a rough TIG weld on stainless steel, for instance, might select a double-cut cylindrical burr and set their die grinder to the appropriate speed. After securing and cleaning the workpiece, they would methodically guide the burr along the weld, blending and smoothing until the surface meets the required standard. For tight corners, they might switch to a ball-shaped burr, before giving the entire weld a final inspection and cleanup. In the end, the result is a weld that is not only structurally sound, but also visually appealing and ready for whatever finishing processes await. Through skillful use of carbide burrs, welders transform rough, unfinished joints into polished, professional results, ensuring both form and function are achieved to the highest standards.